Today we are going to use the sum and difference identities in a different way on different types of problems. We call these triangle problems. Okay, triangle problems. So sometimes we want to find the exact value of a trig function, but we are given information in a different form. Consider the following situations. So in number 5 here, in our yesterday's lesson we went examples 1 through 4, so this is example 5. We are given that sine of some angle A is 3/5, and we are told that that angle A is in quadrant 1. So let's draw that situation. If it's in quadrant 1, then we can draw the angle A would be right here, and if sine of A is 3/5, using SOHCAHTOA, sine is opposite over hypotenuse, so the opposite side, the ratio of the opposite side to the hypotenuse is 3/5. So we can make that triangle like that. And we know from our Pythagorean theorem, Pythagorean triples, this must be a 3, 4, 5 right triangle, right? So if we know that sine of A is 3/5, we can get every other trig function value for A, right? So we know sine of A is 3/5. We know cosine of A would be the copart, so adjacent over hypotenuse, 4/5. And we know tangent of A. Tangent of A would be opposite over adjacent, 3/4. And of course we could get the other 3 trig functions if we wanted to. But those other 3 trig functions are not in our formulas that we are dealing with with this. We are also given that cosine B is 5/13. Cosine B is 5/13. So some other angle has cosine of that is the ratio of 5/13. And angle B is in quadrant 4 this time. So if we draw a picture of that, down in quadrant 4, here's angle B. Okay? So cosine is adjacent over hypotenuse. And so the ratio of the adjacent side to the hypotenuse is 5/13. And I know a Pythagorean triple that will complete this is 5, 12, 13, right? But since this side is going down into the 4th quadrant, I need to make that a -12. So don't forget to put your sign on that. So cosine of B is 5/13. Sine of B would be opposite over hypotenuse, -12/13. And tangent of B, if we need that, will be opposite over adjacent, -12/5. Okay? So in this problem, we are asked to find sine of A plus B and cosine of A minus B. So we are going to be using our identities for this. I'm shocked that I didn't mention this on video, because I certainly mentioned it in class when I taught this. But know that sine of A plus B is not just sine of A plus sine of B. You cannot distribute those. You cannot distribute the sine to those 2 angles. This is an argument on sine. It does not. You cannot distribute there. We must use our identities. So sine of the sum of A plus B, I'm using this identity, sine of the sum of 2 angles. So it'll be sine of the first times cosine of the second plus cosine of the first sine of the second. Just as we did yesterday, I'm just going to fill these in. So sine of A Sine of A is 3/5. Cosine of B is 5/13. Cosine of A is 4/5. Sine of B is negative 12/13. So in a multi-part problem, you might want to jot these values down over on the side. It might help you to complete these more quickly. Okay, so let's multiply this out. So 3 times 5 is 15. 5 times 13 is 65. 4 times a negative 12 will be a minus 48. 5 times 13 is 65. And this will be, so 48 minus 15 will be a 33, and that sign will be a negative. So negative 33 over 65. I can see these as multiple choice answers, so you definitely want to combine your two fractions at the end. Okay? Cosine of A minus B. So I'm using the cosine of a difference formula. So it's cosine of the first times cosine of the second plus sine of the first, sine of the second. So this is cosine A, cosine B plus sine A, sine B. Let me put my parentheses. Cosine of A is 4/5. Cosine of B is 5/13. Sine of A is 3/5. Sine of B is negative 12/13. We have 20/65 plus minus 36/65, and that will be a negative 16/65. And that's how we do those. Okay? Let's try another one. In this problem, let's see how they're going to give us the information. We are given that tangent of U is negative 5/12 with, and they give it to us like this, U is between pi/2 and pi. Well, between pi/2 and pi, that is quadrant 2. So I know that U is over in quadrant 2, and tangent is negative 5/12. Tangent is opposite over adjacent. Opposite is 5, adjacent is 12. I have a negative here, so one of these has to be negative. Well, 5 is going up. The 12 is going to the left. The 12 needs to be the negative because it's going to the left. It's on the negative x-axis. And that makes the hypotenuse 13. So there we are for U. So I know that sine of U is, sine of U would be 5/13. Cosine of U would be negative 12/13, and tangent of U they gave us, right? Let's go to this other one. We have cosine of V is negative 4/5 with V between pi and 3pi/2. Well, that means V is in quadrant 3. So let's draw V over here in quadrant 3. Okay. Cosine is negative 4/5. So cosine is adjacent over hypotenuse, and the hypotenuse is never negative. Therefore, it has to be negative. Again, it's on the negative x-axis. This makes that a 3, and it is going down into, it's on the negative y-axis, so, or it's in the negative y direction, so we make that a negative 3. So let's get our values for that. We have cosine of V. Let's get sine of V. Sine of V will be a negative 3/5, opposite over hypotenuse. Tangent of V will be Opposite over adjacent, negative 3 over negative 4 will make it a positive 3 over 4. Okay, find the exact value of each of the following. We start off with tangent of u plus v. Well, my tangent equation is the more complicated one. That is my tangent u plus tangent v on top, and on the bottom, 1 minus that product, tangent u, tangent v. Okay. Tangent of u, we were given, was negative 5 over 12. Tangent of v we found to be 3/4. All over 1 minus tangent of u is a negative 5 over 12. Tangent of v is that 3/4. Okay, so we have this complex fraction to reduce. So I like to begin by multiplying top and bottom by my largest common denominator. So I see a 12 and a 4, 12 and a 4. So I'm going to multiply top and bottom. Watch how I do this. I'm going to multiply top and bottom by 12 times 4. Okay? Yes, I know that that's 48, but I like to leave it like that because I can easily see what cancels up on top. So here, for this term, the 12s will cancel, and I'll be left with 4 times a negative 5. For this piece, the 3/4, the 4s will cancel, and I'll be left with 12 times 3. Okay, that's why I didn't multiply 12 times 4 and get 48. Okay, but here, I just have a 1, so I need to put that 48 over there. This will be a plus, and then here the 12 reduces with the 12, the 4 reduces with the 4, and all I'm left with is 5 times 3, 15. On top we have a negative 16. On the bottom we have, let's see, 13, 6, carry the 1, so 63 there. So negative 16 over 63 will be the value of that trig function. Part B, sine of u minus v. Well, formula time. That is sine of u cosine of v minus cosine of u sine of v. That's that formula. Okay, let's go get these values. So sine of u is 5 over 13. Cosine of v was given to us to be a negative 4 over 5. Cosine of u is negative 12 over 13. Sine of v is negative 3 over 5. This first term will be negative 20 over 65. This next term will be negative. We have 3 negative signs here, so that's an odd number of negatives, so it'll be a minus 36 over 65. So this will be a negative 56 over 65. Okay. One more example. We are given that secant of m is 5/3, and m is between 3 pi over 2 and 2 pi. That puts it in quadrant 4. Okay, puts it in quadrant 4. I'm trying to find the best spot to put it. I think I'm going to go put it over here. I don't have a lot of extra room. I'm going to go put it over here. Quadrant 4. This will be angle M. Secant is 5 over 3. That means that cosine is 3 over 5, right? So cosine is 3 over 5. this side here must be a negative 4. So I'm going to get that sine of m is opposite over adjacent, negative 4 over 5. Cosine of m, again, is 3 over 5. And tangent of m, might put that up here, tangent of m is negative 4 over 3. Okay? Now we get some information about n. Cotangent of n is negative 12 over 5. And it says that n is not in quadrant 4. Well, if cotangent of n is negative 12 over 5, that means that tangent of n is negative 5 over 12. Not in quadrant 4, though. So which quadrant would tangent be negative in if it's not in quadrant 4? Well, it must be in quadrant 2. That's the only other quadrant that tangent and cotangent are negative in. So we are going to be over here in quadrant 2. And this will be angle N. Tangent is negative 5 over 12. The 12 needs to be negative because it's on the negative x-axis. The 5 will be positive. It's going in the positive y direction. The hypotenuse is always positive, 13 in this case. So we know tangent of n, again, is negative 5 over 12. Sine of n would be opposite over hypotenuse, positive 5 over 13. And cosine of n would be adjacent over hypotenuse, negative 12 over 13. Now we can go and get all of any value that we want from this. So tangent of m minus n, identity time, tangent of m minus tangent of n divided by 1 plus the product tangent m tangent n. Okay? Tangent of m is that negative 4/3. Tangent of n is negative 5/12. Okay? All over 1 plus the product, negative 4/3 times, I should have put parentheses around that, maybe, I don't know, don't really need them, times negative 5 over 12. So we'll have to be super careful, as always, with our signs, right? So I'm going to multiply top and bottom by 3 times 12. Making sure to distribute. So for this first piece, the 3's will cancel, and I'll be left with negative 4 times 12, negative 48. Here I'm going to have a plus. The 12's will cancel, and I'll be left with 5 times 3, 15. Okay, 3 times 12 is 36, times that 1, 36. Here I'm going to have a plus. The 3 and the 12 both cancel. I'm just left with 4 times 5. So this is going to be a negative 33 divided by 56. Not bad. One last little piece, cosine of the sum of m plus n. So our cosine formula is cosine m, cosine n. I know if this is a plus for the cosine formula, I'm going to have a minus here. Sine of m, sine of n. Cosine of m is 3/5. Cosine of n is negative 12 over 13. Sine of m is negative 4/5. Sine of n is 5 over 13. So we'll have a negative 36 over 65 plus 20 over 65, which is negative 16 over 65. Fun with fractions. Going back to triangles, SOHCAHTOA, back where we started trig with SOHCAHTOA. So fun stuff to get back there. Didn't need the unit circle values for today's material.